Hi and welcome to another very exciting tutorial. Today we're going to build this app that you're seeing right here. We're currently loading or scrolling through about 300 photos that are downloaded from Unsplash. And we're going to build this UI in SwiftUI, but we're also going to build this UI that also displays these same, or actually 300 different random images also from Unsplash. So we are going to download all of that content. We're going to display it very efficiently using the new Lazy VStacks and Lazy Grid. And I'd also like to give you a quick comparison to get started. This is why I have two simulators here. So here on the right, this iPhone 8 simulator displays 300 images each in a grid and in this list. And here on the left, we have an iPhone 11 simulator also displaying a list. And as you can see, if I scroll down through that list, this isn't so much fun. It's laggy, it's not really that great, and it's using a VStack. And in this case, we're using a new Lazy VStack that is introduced in iOS 14, and it's going to be fun. So let's explore a lot of what's new here in SwiftUI. We're also going to build an iPad app that uses the great new features from iOS 14, and also here we have these 300 random images in a list and in a random grid. We can close down this new sidebar, and we will also have a look at the new accent color that we can use right here. So we have a lot to do, and if you are still new to SwiftUI and would like to get right into it, have a look at my Udemy course. It is linked in the video description below. It is a great way to get started, and as I said, what you've learned so far is still true, and it's just getting better. Now, if you want to follow along in this tutorial with the Unsplash API, then please go ahead and have a look at the Unsplash API website and register as a developer here so that you can generate your own API key that is really necessary for getting all of the data that we're going to use. It's completely free, but I'd appreciate it if you'd used your own key, even if I forgot to blur my key during this video. Now, this is the first thing that we're going to have a look at. The second thing is the data model that we need to build based on the API requests that we're going to make. We could paste the API call to Safari and then have a look at the JSON response that we'd get. But for everything that's related to web APIs and checking parameters and so on, I really like to use Rested. It's a great and free app that you can download from the App Store. And once I send my request, this is a simple GET request, I get all of the data that I really need. I see the response header, and I also see the response body that we're going to work with. And this is what we get from Unsplash. So we have an ID, we have a created ad, and so on. Just quite a lot of information for each picture that we receive. And now what we are interested in really is the ID, because it's a unique identifier that we can use. We are also interested in the description. For example, here, man in a gray polo shirt, and so on. And then we get a lot of URLs for the different images, for the raw image, the full image, regular size, small, and thumb. And I think that we're good to go using just a thumb image for our grid. It's completely sufficient, and for these demo purposes with our list, I think we can also work with the thumb image. If you need more quality in your application, then just scale up here and maybe use something else. But we're good to go with that, so just keep in mind we're going to work with the ID, with the alt description, and with the thumb image. And as you can see here, this ID, description, and URL is actually a string that we can use. But if we have a look at the type of these URLs, this is again a dictionary that holds a string as a key and a string as a value. So this is something that we have to keep in mind when we design our own data model. But besides from that, we have a string here, we have a string here, and we're good to go. So let's maybe bring up Xcode for now. And here, when we're having a look at this new Xcode template chooser, and then we get the multi-platform template here, and we're going to go with an application. It's not a document-based app, so just go along with the application. We're going to give that a name. Let's maybe call it Photo Viewer, and hit Next and create that on our desktop. Now, this is what this looks like. We have our shared folder or our shared group where we'll add code that is shared between iOS and macOS. We will have some files that are unique to iOS, but now we're going to start with something that we will need on every platform, which is our data model. Therefore, we're going to use a simple Swift file. Let's call this just model. And for now, we're just going to import foundation. And what we need for our data model is a struct, going to call that photo. And to display it using SwiftUI, what we're going to need is the identifiable protocol so that we can display it in a list or using for each to iterate through everything that we're going to get. And to work with the JSON data that we get, we will need to make this decodable. So we have the codable and decodable protocol, and if we just receive data, it is enough to just use the decodable protocol. If you just need both, just use codable. And as I said, and if we have a look at our data model here, we're going to work with ID, the alt description, and the URL. I'm just going to copy that to not make any mistakes, because how we spell these variables is important. So we have a string here, we have a string here, and for the URLs, we're going to have a dictionary with string as a key and string as a value, and that's already our data model. Now, to actually access all of that, what we're going to need, we need to download the information from Unsplash. So we need to make a API call. Therefore, I'm going to create an Unsplash data class, which is going to be an observable object. And since we're working with SwiftUI, we can use observable object in conjunction with a addPublished property wrapper. I'm going to create a photo array here, which is going to be of type photo. So an array of photos. And let's initialize that right here. And the published property wrapper makes it possible that every time we actually update the photo array, we will see a change in our user interface. And for that to work, this needs to adopt the observable object protocol. And with that done, we can go ahead, create our standard initializer here. It's going to get one function call, which is going to be load data. Still have to implement that later, but now let's just call it in initialize, so that once we create a new Unsplash data object, we will initialize the object and then load the data that we can work with. And now what I'm going to need, I'm just going to copy that real quickly, just prepared that here, is a key and a URL string. So this is my Unsplash API key, and you have to paste your own key right here. And this is just the API call. So we're calling api.unsplash.com. We're accessing photos. These are going to be random photos, and we are going to go with the maximum of 30 photos that we'd like to download with the API, or that we get that from the API, and the client ID is equal to your key. So I'm just using string interpolation here to add my key to this string. Now, having done all that, we still need to access our data with a, for example, URL session. This is the way I'm going to use to actually get our JSON data. So let's create a session. It's going to be a URL session. And I'm going to just initialize that with a default configuration, no need to do anything fancy here. And with this session, we're going to create a data task with a URL. So we have to create a URL using URL from a string. This is our URL string. And I think that this can work, so I'm going to force and wrap this. And in the closure that we're going to append to this, which is also going to run asynchronously, of course, we can have three parameters: data, a response that we're not going to work with, and an error object. And using this data and error object, we're going to start with a guard let statement to create a data object and just assign data here. So if that works, then we can work with the data object. And if not, we should give us some information and maybe print that we have an URL session data task error, and then also append this error and show what's wrong here, or just pass along nil. We have no error message to display, and then we will return from this function, because then we cannot continue if we don't have a data object. And the next thing that could go wrong with this task is that we have a data object, but we cannot decode the JSON data. So here in this case, we're going to create a JSON object, and then we try to use JSON decoder, the JSON decoder object, and call decode. And the type that we're going to decode is photo, so an array of photos. So just using that type from our data object. Since this can go wrong, and since we're just trying to do this, we're going to take this code and wrap it into a do block that allows us to actually also catch errors if they occur. So just using error and a localized description to display what might have gone wrong at this particular point. And of course, I actually just wanted to print the string nil here in line 32, because if there is no error to display, our data would be nil. And here's also a K missing. So with that done, we can definitely move forward. And what we can also do now that we have tried to decode our JSON data and put it into an array of photo objects, we can work with these photos that we have received, and we can iterate through all of the JSON data using a for in loop. So for each photo in our JSON object, we're going to append this photo to our photo array that is a published variable that we can work with in our SwiftUI view. But since this needs to be performed on the main thread, appending this kind of data, we need to use dispatch queue main, perform this asynchronously on the main thread, going out of our closure here, and then use self photo array, and then just append our photo. Quickly build that, and we should have a working data model with a load data function. But what's still missing is actually the resume call that we need to append to our closure here, so that we will also perform all of the code that we added as a function to our data task. And if we want to check if all of that works, let's maybe add a print statement here to just print our JSON in line 37. We also need to create one of our Unsplash photo objects. So I'm going to add that to my content view as an observed object, which we're going to use later anyways. So this is going to be random images, and it's going to be an Unsplash data object. And once we run that, we're going to create an Unsplash data object. In the initializer, we call load data, and we should make sure this is an observed object, not an observable object. It's the observable object protocol, but the property wrapper is observed object. Now let's quickly run that in the simulator and see if we get an output. And indeed, here we are. Here are our 30 images that we can use now in our application. So now we can be sure that we can load data, and now we can also go ahead and begin to display it. And therefore, as I said, we're going to use a Lazy VStack, which is great because it kind of works like a table view in UIKit, so that you really only load the data that is displayed on screen. So if you have 15 images, let's say, to display on screen, then only these 15 images are loaded. And if you scroll down to display the 16th image, then the 16th image is loaded and the first image is unloaded, so that you always have only the data visible that you really need. And we can also go with an alignment here as you would with a normal stack. We can set the alignment to leading, for example, and then to display the images we're going to use for each. And for each requires us to pass along a collection like an array. So we have our random images observed object, and in that we have our photo array. Since we made this class identifiable, we can use the ID here and use the key path ID to ID each object by its ID property. And then we can work with a photo in our closure. And now to actually load all of these images properly and put them into an image, we can use a fantastic framework that's called SD Web Image SwiftUI. It's based on SD Web Image. You might already know it. It's excellent, it's well maintained, and works in a very SwiftUI way. So just to get the code, we can work with Swift Package Manager. So we're going to copy the URL for this repository here, click on File, Swift Packages, add package dependency, pass along our Git repository, use the version up to the next major, and then we'll simply download that and make it a part of our project real quickly and hit finish right here. And then we have this SD Web Image SwiftUI framework, and we can use it right away in our content view and just import SD Web Image SwiftUI, build that real quickly, and we are good to go. Now, for each image or for each photo that we get, we can now just create a web image object with a URL. And the URL that we want is stored in our photo in the URLs property, and this is a dictionary, if you remember, that we can access with a string key, and the key that Unsplash uses here is thumb. And now, of course, we cannot use this string, so first of all, we could maybe check if it really exists. I think it exists now, so I'm going to force unwrap it, but still, this has to be a URL. So let's quickly create a URL object from a string, pass that along, and we should have a web image now. And if we make this resizable, then we should also be able to see that in the simulator right now. And here we go, we have our images, but as you can see, we cannot scroll through them at the moment. So we should embed our Lazy VStack into a scroll view. We do not need any parameters here, just pass that along. And as soon as we did that, we should be able to scroll through all of our images right here. So here we go, we can just scroll right up and down. That already works, very nice. So let's make this a little prettier. We've already added the resizable option so that our images can actually resize. So now let's give them aspect ratio. I just want them to fill their container, and we're going to create our own frame. And now also with SD Web Image SwiftUI, we can access the CUI screen, main, the bounds, and the width. And I'd like to subtract 50 so that we have space of 25 to the left and to the right. This is the width of our image. Now for the height, let's go with 200. And for the alignment, let's go with center right here. Then we can give this a corner radius, let's say about 15. And for the text description, we're simply going to use our photo object, the alt description, description, and let's maybe change the font to footnote. And then let's run this again, and we should have the beginning of our application right here. Can scroll very smoothly through our 30 images that we got. Maybe we should also add a padding to our VStack right here. I'd suggest about 20. And for the title that we're not going to see right now, because we're not going to add a navigation view to this content view, but later we can use our navigation title here for the scroll view, and maybe just call that random list, and the other view that we're going to create is going to be the random grid. But for now, let's just go with that. But just notice that I made a little mistake. I actually wanted to add a navigation title as modifier to the scroll view and the padding to the VStack. So let's have a look at that again real quick. And here we are. Yes, so that's what we're looking for. So very nice. We can display these images in that kind of way. Now, I also promised you that we're going to display that in this grid. Now, nothing simpler than that. Let's create a new SwiftUI view. I'm just going to call that, let's say, image grid view. It's also going to be available for both targets, iOS and macOS. So let's just quickly create that. And also in this grid view, we're going to create our new list of random images. So here I just have to use my observed object property wrapper again. Let's create random images. We could also use one single source of truth so that we do not have to download more images and pass it along, for example, in an environment object. But just to see some changes, I'd like to just download new images for both views that we're creating. So let's use Unsplash data here to initialize that again. And now we can actually just copy our code for each block here and paste that into our body here. We want to add this inside a scroll view again. And here we have our for each element, and we need to make some changes. First of all, we also need to import SD web image SwiftUI. What we also will have to do, in this case, we don't want to make this dependent on the screen width. I like to have just a square-shaped image here of 100 by 100. Also do not need an alignment here, but still we need resizable. We need the content mode. For the aspect ratio, we need our frame, and we don't need a corner radius. I'm going to clip that right here, and then we can display it using a Lazy V grid. But for such a grid, we need to define how our columns should be designed. So I would like to have a 3-column layout. So all I have to do is now, outside of my body, I'm going to create a columns property, which is going to be an array. And in this array, I'm going to add a grid item, and I can adjust the spacing here for this item. I'm going to go with 0. And since I want a 3-column layout, I have to pass along 3 grid items here. And now all I have to do is put a Lazy V grid, in our case, into our scroll view, pass along the columns or the column design that I'd like to use. So just pass along columns. And as my closure, I'm going to add for my content my for each block or my for each element that we've just created and actually reused. Now again, for my Lazy V grid, I'm going to add a padding here, and for the scroll view, let's choose a navigation title of random grid. And now, to actually just display that when we start, all we have to do is open up our photo viewer app.swift file. This is our entry point, marked with the @main structure here. And here in the window group, we can just pass along now our image grid view to test how this looks in the simulator. And here we are, having created a quite cool layout. Actually, I haven't tried it this way before, but this doesn't look too bad. Maybe let's just keep it that way. But just to show you that we can actually remove that, we just get rid of the text here, so please just go ahead with whatever you like. So here we have the same thing, just with our square-shaped images. But as I said, I don't think that's too bad. So let's maybe go with that. It has a cool look to it. Now our next step is to actually put our layouts into a tab navigation. And this is something that will only be available on iOS. So let us create a new SwiftUI file. I'm going to call that app tab navigation, and just select iOS as my target, because when we create this app for macOS, then we definitely will not have such a navigation element. So let's create that. And in order for this to work, we need to have a selection and or the possibility to make a selection, and therefore it is good practice to create an extension for our app tab navigation and just create an enumeration. Let's call that tab, and this enumeration is going to get as its cases our two options. We will have a list and a grid, and for our app tab navigation view, I'm going to create a state variable, which can also be private, which is going to be selection of type tab, and we're going to start with list. So this is going to be updated every time we change between our list view and our grid view. And therefore, I'm going to remove this text here. I'm going to create a new tab view here. And as you can see, we can pass along a selection, which should be a binding. And since we want to change something here, we also need to use our $sign to actually access the wrapped value. And now, as its closure, we will create a navigation view for either our content view, which is our list view. We could rename that to image list view. I'm going to go with content view for now. So when we click on, or when we press on our first item, which is going to be a list, then we want to display the content view. And to actually make this happen, we will pass along a tab item here, using a closure with a label, which is going to be list, and we're going to pass along a system image, which we can get from SF symbols. Just going to use list.bullet. And what we can also do here is just write, when we're creating it, passing along accessibility labels for users that use VoiceOver, for example, to not just give them a blank text statement, but make our app usable, which could be, in this case, list layout, for example. And this is the first one now, which should also be a text. This is now our text label. And then we can copy the whole thing, just paste it again, and we'll not have content view as our second tab, but our image grid view. In this case, we're going to have grid. And we're not going to have list.bullet, but we're going to have rectangle .3.offGrid. And if you are wondering, I'm not memorizing them, I'm just reading that from the SF symbols app here. So we have, for example, rectangle.3.offGrid fill, and we're just using offGrid right now. Same thing with the accessibility. This time we're going to use the grid layout as a label, and that's all there is to our tab navigation. It's so simple to create that in SwiftUI. Now, at the moment, when we're having a look at our photo viewer app structure here, then you can see that in our window group, we just have the image grid view. So maybe we should also create a new view and call this navigation, which is not only part of our iOS app, but also of the macOS app. And here, in navigation, what we should do is check what kind of device we're working with. Are we working with an iPhone, for example, or with an iPad app that has a compact size class? And to actually access the size class that we're working with, we can use the environment property wrapper just to access something like, for example, the horizontal size class, which is going to be a private variable called horizontal size class. And by accessing this using this property wrapper, we can check in our body if our horizontal size class is equal to compact, for example. And in that case, if it's compact, then we're going to display our app tab navigation. And in any other case, we're going to do something else, which we're going to have a look in a second. But as you can see, with this approach, we still get a function declares an opaque return type, but has no return statements in its body from which to infer an underlying type error. So to avoid that, what we have to do is make sure that our compiler knows that this is a child view producing closure. And to do that, we can use the add view builder to create a view that supports multiple children. And now that this is done, we can, instead of passing along image grid view, we can pass along our navigation and run this in the simulator. And if we have a look at that, then as you can see, we have a random list, and we can use our tab bar and switch between our random grid and our list. Isn't that cool? Now, as I already said, we're going to use the accent color feature that comes with iOS 14 to give our app a little more individual look. And for that, we're going to open up the assets folder. And as you can see, in addition to the app icon, we now get an accent color. And it's very simple to work with this accent color. We simply have to open up the attributes inspector. Let's maybe show the color palette. And then what I did to select this color was actually just to pick one of the colors that we're using for our code here. I used this magenta or pink color, copied the code, went back to assets, and actually we could also drag and drop that right into this color field here. And if we run our application again, then you will see that the default system color of blue has been replaced with our magenta color for the tab bar icons, for example. And if you had other UI elements, this change would also be reflected there. So having a look at that, there is something quite surprising here. We do not see our grid view. There are no images, and I don't have any items here. So let's maybe check out what's the problem here. We don't get an error message. We get our JSON response. Let's quickly have a look if there is a null in this response. And indeed, there is one null that we found, and it says expected string value, but found null instead for alt description. So this means that not every Unsplash photo has this data point or has this piece of data added to a record, which means that so far we had luck that we saw images every time we found that, or every time we loaded our application. But let's make a quick change to our data model, which is simply using an optional value here for the alt description, because this is optional in that case. If we build that now, we should get some errors because we're working with a optional value here. For example, every time we use this alt description of a photo. So let's make a quick change here and have a look at photo and the alt description. If this is not equal to nil, then we can display our text. And we're just going to copy that. For our not grid view, let's quickly build that. Is there a problem? Oh, of course, we need to unwrap now our alt description. So if we found that it is not nil, then we can do that. Let's also go into our content view and paste that right here, build that. And this works. Run it real quickly to see if we get our results. And indeed, here we are having our list and having our grid. So this looks very promising. Let's do it one more time. Let's see if we're still lucky. And it still works. So this should definitely correct this error that we found here. Now let's move on with the last piece of user interface that we need, because we also want our app to run on iPad. And this is going to work not with a tab navigation that is only available on iOS. It is going to work with a sidebar navigation, which we can make available on both iPad OS and macOS. So let's keep both targets here. Let's call it app sidebar navigation. Hit create. And we're going to place that somewhere here. And the sidebar navigation works kind of very similar to tab bar navigation. So inside this struct, I'm going to create an enumeration, call it navigation item. We're going to have two cases. We have a list and we have a grid. These are our two friends that we're going to work with. And then we also need, just as with the tab bar, we need a private state variable that is going to keep our selection. And it's going to be a set with the type navigation item. And we're initializing that with our list navigation item. So this is where we're going to start. Now, for displaying our sidebar, we're going to build that very similarly to a body. So we're going to create a variable here, call it sidebar, and it's also going to be some view, so just as the body. But here we're going to create a list now with our selection that we pass along as a binding, and also we want to access it. So we have to use the $sign to access the wrapped value. And as soon as we have this list, we're going to generate our navigation link in this case. So it's really working just as you would expect with a standard list in SwiftUI. So we have our navigation link. We have a destination, which for our list view is going to be the content view. And let's give it a label. It's going to be called list with the system image list bullet, right, like this. And then we will also have, just as with the tab bar, we're going to have an accessibility label, which is also going to be a text, call it list layout. And last piece is the tag that we'd like to use. And this is the navigation item and the list. So this is just the elements from our enumeration. And with that, we can just copy this navigation link here, paste it one more time. Then we're going to have the label grid. We're going to have rectangle.3.offGrid as with the last one. And we're going to have the grid layout as a accessibility label, and also here we're going to go with grid. Let's quickly build that and see that this works, and it does. And so this is our sidebar list, very simple. Let's give it a title with navigation title, which is going to be content options. And also what this requires is a list style. And here we're going to initialize that with sidebar list style, which is coming as a pre-configuration. And this now is our sidebar. And now for our body, we're going to create a navigation view, navigation view. And in this navigation view, we'll pass along our sidebar and a text that just says select content style. Let's give this a frame with a max width of infinity and a max height of infinity. Quickly build that again. Here we have missed quotation mark, and here I'm sure I spelled something incorrectly. So max width, missing a D, and now we're good to go. Now we have an app sidebar navigation that we can use if we're on an iPad. But how do we know that we are on an iPad? So if you remember what we did in navigation, we checked if the horizontal size class is compact. And this means that we're either on an iPhone or that we're displaying our app in a very narrow window or in a compact window. So in any other case, we actually want to display not the app tab navigation, but the app sidebar navigation. And run this now on an iPad. Let's say we go with the 11-inch. I think we can forgo this error. There isn't an error, actually. So once we run this in the simulator, let's maybe rotate it here to get it in landscape mode right away. And here we are. We have our content options, we have our list, we have our grid, and we should maybe have a look at the navigation, again, app sidebar navigation, and instead of our destination content view for the grid navigation link, we should also use image grid view here. Let's quickly run this again and see the results. So we have our list, close that down, really cool list, and we have our grid. So this is really amazing. So we have this great new feature of the sidebar. We get that in a very simple way. We have our accent color. You have seen how to do so much in SwiftUI now, and the coolest thing is that this app could run right now in macOS, but it doesn't. And the thing is that it just does not run on macOS because the SD Web Image SwiftUI framework isn't yet optimized for using or for usage together with macOS. There are several problems. For example, we do not have the UI screen, main bounds, and so on macOS. That wouldn't work. But if we'd like to use SD Web Image SwiftUI now in our iOS project and create our own image processing and image downloading, caching, and so on features for our app, what we could do is use the ifOS system or the ifOS code here now. And if we check if the operating system is iOS, then we'd like to do this. And then we create an end if, and we can also use else here. And for example, use another image system or our own if we have one. But you've seen that we've built the structure for an application that could run on both iOS, on iPhone, on iPad, on macOS. We also made sure that, for example, app tab navigation is only part of the iOS bundle because a tab bar wouldn't make so much sense on macOS in our case. So let me just quickly remove that. Please let me know If you're interested to see more about apps that run on both iOS and macOS, in the comments below. Also, let me know if you enjoyed this video with a thumbs up. Subscribe to this channel to not miss any future tutorials. And just to go over that one more time, what we have done, we have an application that works both on iPad and on iOS. You can see that once we are no longer in the compact size class, we get a sidebar. Once we reduce the size to a compact size class, we get a new user interface here with the tab bar, and we have the same thing on iPhone, so really cool with a tiny amount of code. We've seen a ton of new features in Xcode and the cool new Lazy VStack and grid that enhances performance so much. I thank you so much for watching, and I'll see you in the next one. Bye.